Before we get into actually using arithmetic formulas and geometric formulas, we'll take a look at where they actually come from. Not really essential that you know where they come from, but for those of you who like knowing why something, this is the video for you. Okay, so we have the arithmetic formula, and I have an example here that'll help us get to what we're looking for. And I've set up an example that is terrible, apparently. So I'm going to change the example on the fly here. These numbers are not what I want. Let's start with 6, though. Let's do 13, 20, and then 27. Okay, that's much better. Okay, anyways, so we see from looking at this that I am adding 7. And you see here, I've asked, okay, what are the next couple terms? So if I were to do that, pretty simple there, I'd add 7. So I'd get my 34, and I'd add 7 again, and I get my 41. But then notice I have 3 dots, and I'm like, 50? Do I have to do this 50 times? Now, maybe you wouldn't mind doing it 50 times, but I think there's got to be a better way, because it's a pattern, right? I'm adding 7 each time. Okay, so let's get some notation down. So each of these are A, so this is A1, this is A2, this is A3, this is A4, so this is A5, A6, and then we want to go all the way down to A50. We want to know, well, what's that 50th term? So how can I use this? Well, these are term numbers, right? So I'm going to say that A sub n is the nth term. And I want to see if I can build a formula that will get me to any nth term based upon just n, if I know the term that I want. So n is the term I want. Well, let's see if we can get there. So I'm going to use these term numbers. So we know that A2 has some sort of relationship with A1, right? It's A1 plus 7. And I know that A3 has a relationship with A2. It's A2 plus 7. In fact, we could take all of this and write what's called a recursive formula. Now, the recursive formula is not going to help us too much to get to that 50th term, but it will help us to get to where we're going. So the recursive formula here would be A sub n, our nth term, equals A sub n minus 1. This means the previous term, and then plus 7. So there's a recursive formula. So that was going to work if I do A4 equals A3 plus 7, and so on and so forth. So if I wanted, say I wanted the 7th term, so n equals 7. So A sub 7 would equal A sub 6 plus 7. So that's going to equal 41 plus 7, so 48. So 48 is my 7th term using my recursive formula. But my recursive formula, again, isn't going to help me get to that A50, or what if it was A5000 term? It's not going to help me to get there. It's still going to have to calculate all the other terms before it. So we need a better way. So I'm going to just copy this for a second so I don't have to have all this mess right here. I'm going to delete this portion out of the way and get rid of this. Okay, good. Good enough, okay? I'll clean it up a little bit more. All right, let's get rid of that. Okay, so working in red right here. Notice if I were to add A1 at the beginning, well, that's kind of where I start, right? So I'm starting at A1. Oh, I have a little selection right there I got to get rid of. All right. So I'm starting at A1. And that's going to equal, well, what does that equal? It equals 6. I actually needed that for my recursive formula, but that's okay. So I start at 6, then I add 7 each time. So how many times have I added 7 to this first term? Well, I've added it 0 times, right? And how many times have I added 7 by the time I've gotten to the second term? Well, I've added 7, 0 times from the first one, but 1 time from the previous one, right? So by the time I get to the third one, well, how many times have I added 7? Well, not this one. 2 times. I've added it 2 times. And how many times have I added 7 by the time I get to the fourth term? Well, 3 times. And notice, if I want the fourth term, I've added it 3 times. If I want the third term, I've added 7 2 times. Well, repeated addition is just multiplication. So that's where we get our, what I'm going to call the explicit formula. Explicit means I get my term without knowing any of the other terms. So my explicit formula for an arithmetic is a sub n equals, well, my starting term, so a1, and then plus, well, I'm doing 7, right? But in this case, that's my common difference, so my difference, and then I multiply that by however many times I've added it. So on the first time I've added it 0 times, 1 time, so if this is term 1, this one's term 1, and it's 0 times, and this is term 2, because it's term 2, and I've added it 1 time, and this is term 3, and I've added it 2 times. So if this is n, then this is n minus 1. And that's how many times I multiply it. So n minus 1. And that gives us our explicit formula for an arithmetic series or sequence. Okay, so let's take a look now at a geometric sequence. And let me make sure these numbers aren't screwed up. All right, it looks like they're fine. And I say times 2, times 2, times 2, times 2. So I can get these other ones pretty quick. 32 and 64 and 128 and, well, the 30th. How many times am I going to multiply by 2? I don't want to do that 30 times. And the thinking behind this one is similar to the thinking behind the arithmetic one. So let's just set this up a little bit. So on my first term, I just started 2, right? And then that would be term number 1, n1. And then a2, well then that is a1 times 2, because I multiply by 2, right? And that's our second term. Now I multiply by 2 1 time, right? And then a3 is a2 times 2. So the previous thing, this last one, times 2, that was n equals 3. Now, how many times have I multiplied by 2? Now, on the first one, I multiplied by 2 0 times. I multiplied by 2 1 time. Now, how do I know? How am I getting that I multiplied by 2 on this third one 2 times? Well, this time and this time, right? So twice I've multiplied by 2 from the beginning. So a4, that's a3 times 2. So n equals 4, and I've done 3. So this is my n column. This is an n minus 1. So let's take a look at our recursive formula. Now I'll actually do the complete recursive formula. Recursive means I need to know the previous term, and I need to know the first term. So in a recursive formula, my first term is going to be a1 equals 2, and then a sub n, that's the term I want, is going to equal a sub n minus 1, that means the previous term, times my ratio. So in this case, my ratio is 2. So in this case, I could write a recursive formula, and it would be called a1 equals 2, and a a sub n equals, I'm going to put the number in front. My ratio was 2 times a sub n minus 1. The order that you put these in really doesn't matter. Now this means the term wanted, and this would be the previous term. So just out of curiosity, what would be a sub n minus 2? Well, that would be the previous two terms, right? All right, explicit formula. That's where we really want to be. Actually, I'll write this in red because it is important. This is the one that we're trying to figure out. So our explicit formula is going to follow that same logic as before. A sub n. Now I have a starting point. A sub n, or a sub 1. That's our first term, so we need to know where we start. Times our ratio. But then what comes next? So I'm repeatedly multiplying. So by the time I get to this fourth term, that's 2 3 times. Do I write that as 2 times 3? Well, that's 6. And is 2 times 6 16? No, 2 times 8 is 16. So 2 times 2 times 2 is 2 cubed. Yeah, 2 times 8 is 16. So r to the n minus 1. This is an exponent. And that gives us our explicit formula. So bottom line, what is it that we figured out? Well, hopefully you were able to follow along, but we found an explicit formula for geometric and arithmetic sequences. So the arithmetic one is a sub n equals the first term plus the common difference times n minus 1. And geometric is, that's a 1, should be a 1. The common ratio times the common ratio to the n minus 1.